All right, let's look at the evens on the review worksheet. Worksheet 7, mixed integration. I'll do all the evens. And I think I'm going to do these kind of fast because I know from experience what works well for U and DU. You just got to do a lot of them until you get to the point where you start recognizing, like on number 2, the derivative of 3x squared is 6x. That's almost what I have. So let's let U be the exponent. Du would be 6x. So that 6x dx, that almost matches what I have. So I'll put a 6 and a 1/6 out front. So 1/6 integral 6x dx is du, 5 to the u du. Antiderivative of 5 to the u is 5 to the u, but divided by natural log 5. There's also a 6 in the bottom. So 5 to the 3x squared over 6 natural log 5 plus c. Number 4. Again, u du. If you use the bottom, then du is pretty much the top. It looks a little bit like arctan, but arctan wouldn't have an x in the top. So u is x squared plus 2. Du is 2x dx. So I can put a 2 up there to make it work, and then a 1/2 out front. So the 2x dx is du, and 1 over u. So that'd be natural log of u. So 1/2 natural log of the absolute value of u, and u is x squared plus 2 plus c. Multiple choice, x squared plus 2 is always positive, so they would probably drop the absolute value bars because they're not needed. But free response, either answer would be fine. Number 6. Okay, one of the primary rules is if the top's bigger than the bottom, then you've got to long divide. Maybe synthetic divide, but this one's going to be a long divide problem. If the top power is bigger than the bottom power, top degree is greater than or equal to bottom degree, you've got to divide. So something times x squared gets me x cubed. That would be an x. Multiply it back. And subtract. So I get negative x plus 1. Nothing times x squared is going to get me negative x plus 1. So my answer is x plus negative x plus 1 over x squared minus 1. Let's see, I'm trying to think if I did that right. I think so. X squared minus 1 will factor into x plus 1, x minus 1. This is kind of yuck, but so I'm going to rewrite that as 1 minus x, and then in the bottom, x minus 1, x plus 1. The 1 minus x and the x minus 1 will cancel, or at least cancel to a negative 1. So antiderivative of x is x squared over 2. Antiderivative of, take the 1 out, of 1 over x plus 1 is natural log, because if u is x plus 1, then du is dx. Probably not needed on this much, or this part of it. Minus natural log x plus 1 plus c. It's kind of a yucky one with a lot of algebra to begin with, a little bit of algebra again with reducing, and then the calculus at the end. Number 8, top power is bigger than the bottom power. Got to divide, although this is an easier divide problem because I can just x squared over x is x. 1 over x I'll just leave as 1 over x. So now I can integrate those. X squared over 2. Antiderivative of 1 over x is natural log of x. You just got to know that. And then this is the first one on the page that has definite integrals. It has the bounds there. So I need to do from 1 to e. So e squared over 2 minus natural log e minus, so top bound minus bottom bound, so now I'll plug in 1 minus 1/2 minus natural log of 1. Perfectly acceptable free response stop, but multiple choice, we can clean that up a little bit. E squared over 2. Natural log of e is 1 minus 1/2. Natural log of 1 is 0. So e squared over 2 minus 3/2. Okay, I'm thinking u for the bottom, but then du would be 2x minus 6. And I don't have any x's on the top, so that's not it. An x squared in the bottom, though, could be arctangent. So let's see if we can sort of force this to work. Like, I want this to be a perfect square. So half of negative 6 is 3. Square it, we get 9. So that means I need to do the minus 9 out here. I'm going to take this 3 out front. Okay, so now that does look like arctangent. With this being u equals x minus 3. A would be square root of 5, right, because it's supposed to be u squared plus a squared. So 3 arctan of u over a. But arctan has 1 over a up front as well, plus c. Number 12. Starred, asterisk, whatever. Like, you're going to see that one again. If you think u is the bottom, that won't work, because then du is going to have an e to the x in it as well, so that won't really help. But e to the negative x kind of reminds me that I could write that as 1 over e to the x. Now, admittedly, that makes things worse rather than better. But if I then clear out that e to the x by multiplying top and bottom by e to the x, so admittedly this is an algebra trick that we're doing right here. But now, if I do a u substitution on the bottom, this is going to be good, because du is e to the x dx, and so there's my du, and bottom is u, and the antiderivative of du over u is natural log of u, or e to the x plus 1 is u plus c. Once again, e to the x is always positive, so they might drop the absolute value bars for this one, because the argument is always positive. So that's a bit of a tricky one, but your first step there, once you realize there's nothing much you can do to start with, to rewrite that negative exponent, and that kind of gets you on the path toward getting something that'll work with a u du. So that was 12, so let's do 14. If antiderivative from 0 to 8, f of u is 6, then what's this? What the heck is that? Well, I think if I let u be the argument of f, then du will be 2x, so at least I'll be on the right path, I think. So I can put a 2 and a 1/2. So 1/2 antiderivative. I need to be careful, not from 1 to 3 anymore. Those are x values, and I'm switching to u values. So f of u du. But I need to put, instead of 1 and 3, I need to find u of 3. 9 minus 1 is 8. So my top bound is 8. U of 1, nope, excuse me, U of 0. Nope, U of 1, I was looking at the wrong thing. U of 1, because x is 1. 1 squared minus 1 would be 0. And now I see why they gave me this. It looked a little strange at the beginning, but now I understand why they gave me that. So half of 6 is 3. So that one looked really ugly to begin with, but with a key U substitution, it fell out pretty quick. Number 16. F is twice differentiable. Selected values of f prime are given in the table. It gives me some f prime values. Part A, the antiderivative of the second derivative. I don't know what f is, but the antiderivative of the derivative, this antiderivative is going to peel off one of those derivatives. From 2 to 3. So I still have no idea what f is, but I've got a table with some f primes in it. So if I plug in 3 minus plug in 2, f prime of 3 is 6, f prime of 2 is 2, so my answer is 4. Let's do B, and then I'll leave C alone because it's pretty similar to B. Okay, ugly looking stuff, but if I let U be that, then du is close to that. So U is x squared plus 3. By the way, you picked up on a pattern here maybe from 14 and 16. If you're doing f of something that's complicated or ugly, let U be the argument of f. And frequently that'll take care of it for you. 2 and a 1/2 to make the du show up. I'm switching, so I'm switching from x to u, so I want to be careful and not put 1 and 2 in there. Okay, so now this looks a little bit like part A. Antiderivative of the second derivative would be back to the first derivative, but I need to fix these limits. So the upper limit is 2. 2 squared plus 3 is 7. The lower limit, in terms of x, is 1. U of 1, 1 squared plus 3 would be 4. So 1/2. Antiderivative of the second derivative would be the first derivative, and then from 4 to 7. So I'm good now because I have f prime from 4 to 7, and I do know 4 and 7. So half of f prime of 7 minus f prime of 4. Don't be thrown off by the fact that this says u and this says x. X is just telling me which variable to evaluate. U, but these are u limits, so it's fine. When I plug them in, then I just need f prime of 7, and it doesn't matter whether that 7 was x or u or y or z. If 7 is the input, then f prime is 11. If 4 is the input, f prime is 8. So 3/2. Part C is nearly identical. U will be the input, or U will be the inside. Du will be close to that. Probably have to slide the 5 out, switch the limits. Pretty similar to B. Number 18. Let's change 18. We're going to change 18 to be natural log of x all to the 8th. Makes it easier. So let's let u be natural log of x. We almost always do that if there's a natural log in there, because I don't know what the antiderivative of natural log is. So this might mean I don't have to find the antiderivative of natural log. And there's dx over x. So this is good news. That's du. So u to the 8th du, that turned into a really easy problem, hopefully. So antiderivative of u to the 8th is u to the 9th over 9. I'm going to rewrite that as 1/9 natural log of x to the 9th plus c. Number 20. Yuck. Except that the numerator looks ugly, but the denominator looks a little bit like antiderivative of du over a squared minus u squared. That's arc sine. So this is, I think, arc sine of something if a is 2 and u is secant. Now, that's going to have to fit with the rest of this problem, so I'm not for sure yet. But du then is secant tangent, and that's perfect. That's great news. So now all of this is du. So antiderivative. Careful with the limits again. We're switching, so I don't want 0 and pi over 4 there. I'm going to have to change those. Du over square root of a squared minus u squared. And now it looks exactly like arc sine. So I know that's arc sine, but let's find those limits here. Secant of pi over 4. Let's see. Cosine of pi over 4 is root 2 over 2. So if I flip that, I end up with the square root of 2. Plug in 0, secant of 0. Cosine of 0 is 1. So if I flip 1, I get 1. So my limits aren't terrible if you know your unit circle. Okay, so that's arc sine of u over a. So secant of x over 2. And arc sine does not have the 1 over a out front. That's only arctangent that has that. And then from 1 to square root of 2. Yeah, that's right. Except I don't know what the secant of root 2 is, so I'm going to check this one in a minute. So arc sine of secant of square root of 2. That doesn't sound right. Okay, what you didn't see was me go check with Miss Murray to see what I missed. And I didn't miss anything. It's just a bad problem. It's not a bad problem, it just doesn't have a nice answer. Because you can't take the secant of square root of 2. Well, you can, but we don't know what it is because that's not a unit circle value. So we're going to plug it in and leave it like that. Arc sine, and then we'll plug in 1, and it's the same issue. This is not what angle has a secant of root 2. That would be pi over 4. It's if the angle is root 2, what is the secant? You're like, well, I don't know. That doesn't really make sense to me. So we just leave it like this. Kind of an ugly answer, but it's an accurate answer. Okay, 21. Oh, we're doing a class. We're doing just evens. 22 looks a little bit like number 12. No, because if I take the derivative of e to the 2x, that's not going to work for me. So this looks like something squared. And if u is e to the x, du is e to the x. And that's always kind of tricky because which one do I use? Except that this will be du. This will be u squared, and if I'll let a be square root of 3, well, I just wrote e to the x for u. This will be du over a squared plus u squared. That's an arctangent thing. Again, this is one of those where you just have to recognize that that's a squared, and the derivative's in the top, so that's arctangent. Arctangent of u over a e to the x over square root of 3. And then remember, arctangent has the extra a in there, so you get a 1 over a out front, plus c. Looks ugly, but if natural log's in there, you're almost always going to let u be natural log of x. Du is 1 over x dx. And, okay, so there's dx over x, that's du. 7 can just slide out front, don't worry about him. And this is starting to look like arc sine, a squared minus u squared. So if I let a be square root of 5, then it's exactly arc sine. 7 arc sine of u over a, natural log of x, over square root of 5.
Good morning, King.
No limits to worry about, so just plus c. I'll have to ignore Preston in the background. Antiderivative of natural log of secant, that's one that we just have to know. There's no secret to getting that.
And now for the Texas Fly.
It's the natural log of
Texas Fly.
secant plus tangent.
One state, under God, one is indivisible.
Plus c.
Thank you.
Again, no magic to that. That's just memorizing. All right, that's the evens. Hopefully you watch the odds in class. And good luck tomorrow.